Hey guys, Dr. Mark Shankman here, again with you, talking about the Obesity Project. Today, episode 5, Mastering Insulin, which is the real secret to weight control. So, just a little bit about myself. If you have not followed my content before, I just want to let you know I am an oral and maxillofacial surgeon. You can see I'm actually wearing my scrubs today. Um, and although my patients don't necessarily require obesity knowledge, I do run into a lot of obese patients, of course, and as an oral surgeon, I do general anesthesia, and managing someone's airway is of significant importance to me. And my personal journey, as well as my professional journey, have really steered me into kind of understanding obesity, understanding uh, why people become insulin resistant, understanding the nature of type 2 diabetes and other chronic illnesses. So that's where all of this comes from for me. So today we're going to talk about hormones, and we're going to really focus on insulin. In upcoming episodes, I'll talk more about different hormones, but today we're going to focus on insulin. So I want to first start off with basically what a hormone is and how it works. So a hormone is a message sent by the body to regulate a certain system. And there are hormone regulating systems throughout the body, um, metabolism and sex hormones control ovulation and spermatogenesis and all of these other things, secondary sex characteristics and whatnot. Growth hormone, there's lots of different hormones circulating through our bodies that control the various systems of our body. Our bodies are entirely controlled and regulated by hormones, and the brain, and particularly the pituitary, are the primary mechanisms for controlling these hormones. However, I want to talk a little bit about how a hormone works. And you can see in the picture behind me, this is a diagram of how insulin and the insulin receptor work. So essentially what the hormone, how it works is the hormone itself is the key, and the receptor on the cell surface is the lock. So it's basically a lock and key kind of system. You can see in the diagram behind me, it's always hard to figure out where, there. And you can see the insulin, sort of matches up with the insulin receptor. Initially, the glucose receptor or channel is closed, and then you can see in the other diagram to my right, you can see that once insulin binds with this receptor, it actually opens that glucose channel and allows the glucose to enter. So that's basically how all hormones work. There's a hormone and a hormone receptor. The receptor opens channels and allows things to happen. So, like for instance, in a nerve cell, there's an action potential, a chemical crossing of the channel that changes the electric potential of the cell. So all sorts of hormones regulate those types of things. And of course, there's plenty of hormone control over insulin and many other hormones. So um, insulin does facilitate and is required in many, many cells to allow glucose to be taken up by the cells. Now, there are some body types of systems or body cell types that will allow glucose to enter without insulin's facilitation, I guess. Like muscle cells do have sort of a backdoor way of allowing glucose in, but for the most part, most cells require a hormone to bind to its receptor to allow a channel to open and allow the molecules to enter the cell. So here's the interesting thing about insulin in particular, and that all cells in the body actually have insulin receptors. Insulin is one of the few hormones that has vast control over almost all types of cells within the human body. And It does have numerous functions, not at the very least is allowing glucose to enter the cell, but does control fat metabolism and hormone regulation in the fat cell and a bunch of other things. But all cells within the body actually have insulin receptors. So I do want to talk a little bit about diabetes because this is kind of an easy classical way to understand how insulin works. So in type 1 diabetes, this is what used to be called childhood diabetes, although children can now get type 2 diabetes from obesity. But type 1 diabetes basically means it's an autoimmune disease that attacks the islet cells of the pancreas where the insulin is produced. And when those cells are destroyed, the person now doesn't have the ability to create their own insulin, or they're at super, super low levels, really insignificant levels to um, maintain health. And type 1 diabetes, if untreated, is absolutely fatal. So insulin is a very necessary hormone, and without it, we will die. So type 1 diabetes is basically either low or no insulin production. And the way these people stay alive is through injecting insulin into their bodies that is made outside the body. In type 2 diabetes, we actually have insulin, but our bodies become insulin resistant. And as the resistance increases, we need more and more insulin to allow it to do its job. And so type 2 diabetes is actually an overproduction or a hyperinsulinemia or an elevated level of insulin in the body. So it's really important to understand those two things because especially as we move along in the education, we're going to be using those two forms of the disease to explain how insulin works and how it controls things. Now, insulin basically causes glucose to move out of the blood and into cells, into body tissues. And as you can see in the picture behind me, it's pulling that glucose out of the blood and then putting it into that cell. But insulin will drive down blood sugar levels in the blood. So that's its, primary mission, although it has many other functions as well. In addition to reducing blood glucose or blood sugar, the liver converts the glucose into something called glycogen. And this is a process called glycogenesis. And it is the sort of quick, easy storage system for sugar molecules. So as I mentioned in yesterday's video, I kind of reviewed this, but I think it's important to kind of go over this again as we move through what insulin does. Um, the liver takes all of these glucose molecules and kind of connects them together into this strand of glycogen and then stores it away. Glycogen can be stored both in the liver as well as in muscle tissue, and those are the two primary sources of glycogen. But in addition to the glycogen, liver can also convert the excess sugar or excess glucose into fat. And that process is called de novo lipogenesis. And so it's actually taking sugar molecules and converting them into fat molecules. Now, most of you have probably heard of triglycerides. What triglycerides are is the fat that the liver is converting things into. So it's basically three chains of fatty acids attached to a glycerol molecule. So the glycerol is sort of the backbone, and then these three fatty acid chains are attached to it. And it's really those fatty acid chains that are being used as energy. They're being added to the glycerol and then being cleaved from the glycerol to be used as energy. But the liver converts the extra sugar into fat. So these are all the functions that these are all the functions that the insulin causes when the insulin levels are high. When the insulin levels begin to drop, now we have another hormone called glucagon, which basically has the opposite effects, where insulin drives the sugar into fat cells and into glycogen storage. Glucagon does the opposite. It basically cleaves the glucose molecules from the glycogen and also releases the fatty acids from the fat storage. So here's an interesting thing about insulin. And this is one of the keys to understanding that insulin is paramount when it comes to obesity. And that's if I take a normal, healthy, lean person, someone who's not obese, and I inject them with insulin, they're going to gain weight. And we see this all the time in type 1 diabetics. So, type 1 diabetics require that insulin to stay alive, but they also will actually gain weight as a result of that insulin injection. Now, research has actually demonstrated a very high correlation between high fasting insulin levels and obesity. So, normally the insulin levels come down between periods of eating. But in obese people, that insulin level stays very high, and of course, in type 2 diabetics, it does as well, and in some other situations. But we're focused primarily on obesity right now. But those high fasting insulin levels are found within obese people. So that's an important characteristic to understand. Now, we can also test the insulin causing obesity theory by simply injecting insulin into people that don't need it, the non-type 1 diabetics. And actually, this is done all the time by many, many physicians for treating type 2 diabetes. Now, what's interesting about type 2 diabetes that is really kind of weird if you think about it, and this we'll talk a little bit about how the medical profession kind of, is off the beaten path on type 2 diabetes. But if you inject insulin into a type 2 diabetic or into a lean person that is not obese, they will gain weight, and these physicians see this all the time in their type 2 diabetics. So where I said what's kind of doesn't make a lot of sense when you think about treating type 2 diabetes, which is an overproduction of insulin and an insulin resistance, so the cells are not responding to the insulin that is there, that okay, to maintain blood sugar levels, the insulin's not working as well. So you have to inject insulin to make the cells sort of listen to the insulin. But if you think about it, it makes no sense. If someone has too much of something, why would you give them more of it? So that's the part that really doesn't make sense. But really, that boils down to the fact that the medical profession in general is focused on blood glucose and not on insulin levels. And that's where really in my opinion, the medical profession goes wrong. But we'll address that a little bit more in later episodes. That's definitely a topic for a later episode. So here's the other part that's really interesting about injecting insulin is if we inject insulin into patients that actually willingly reduce their calorie intake, we should think, maybe one outweighs the other. And what we see routinely, and they've done studies where they've actually decreased by 300 calories each and every day while receiving insulin injections, we'll see those patients continue to gain weight. So this is proof that insulin causes obesity and proves that theory. Okay, so if you inject insulin in a lean person or in a type 2 diabetic and they gain weight, that's proof in the pudding that insulin causes obesity. Another example of this is these are really rare, but in patients with something called an insulinoma, that's a tumor that produces excess insulin, we see them gain dramatic amounts of weight. And interestingly enough, once the tumor is treated, they lose all that weight again. So this is, again, more proof that insulin is the control mechanism for weight gain and obesity. So if insulin causes weight gain, you may be asking yourself, can lowering insulin cause weight loss? And the truth is, the answer is absolutely yes. And we see this all the time in untreated type 1 diabetics. And this is why I wanted to go over type 1 versus type 2. In type 1 diabetics, they basically have no insulin and they're wasting away no matter how many calories they eat. They could eat 2,000 calories, 3,000 calories, and they are losing weight. They are wasting away until they basically die. So insulin is absolutely critical to keep those folks alive. But without that insulin, we can see they continue to lose weight. So absolutely, if you decrease insulin levels, we can decrease weight and we can cause weight loss. There's also and this is a really fascinating prospect as well, sad but fascinating. There's something called diabulimia. And in diabulimia, this is where type 1 diabetics, knowing they have to inject insulin, but knowing that it's going to cause them to gain weight, they actually will purposefully inject themselves with lower levels of insulin than they need simply to keep the weight off. And it's really a form of eating disorder in type 1 diabetics. But it shows the power of how effective insulin is in creating weight gain or weight loss. So yesterday I touched on the fact that weight is controlled very closely and very tightly by the body, and those systems are in place to maintain a body set point. And yesterday I said that hormones control that set point. Well, here's the proof in the pudding is that insulin is actually that primary hormone which determines the set point. And so what this means is that if your set point is too high, if your weight gain is occurring and your set point is being increased so that you continually gain weight, that means that your insulin levels are too high. So insulin levels being too high creates a higher set point. And here's the other thing that's super important is that obesity is hormonal, not a caloric imbalance. We talked about how even if you decrease calorie intake but increase insulin, you're going to still continue to gain weight. So obesity is hormonally controlled, not a caloric imbalance. Now, that's not to say that calories are not important. Calories are. But as I mentioned yesterday, the calories in and calories out method, not wrong, but just too simplistic. And really, hormonal control is what's really important. And obesity is controlled by hormones, not by calories. So I do want to touch on one other hormone really briefly, only because it is sort of insulin's opposite, and that's leptin. So whereas insulin drives fat storage or storage of energy into the energy storage vehicles of glycogen and fat, leptin actually is the reverse of that. It reduces fat storage. And not only does it reduce fat storage, but it's actually a satiety hormone. It creates the feeling of satiation or feeling full after you eat. And so what's interesting is really what we should see in most individuals is as if insulin goes up, leptin goes down, and vice versa. And what we actually see in obesity is that leptin and insulin levels are actually pretty high. And this is an evidence of not only insulin resistance, but also of leptin resistance. And if you're becoming leptin resistant, then that means you're not getting the satiation that you should. So they did a study where they looked at lean patients, and they noticed that after someone ate, the insulin levels rose as we would expect, but over time, the leptin levels rose as well, which increased satiety. So, it was a response to the food, and yet in the obese patient, leptin decreased instead of rising. And so basically what it was saying is the brain was not sending messages to the rest of the body to stop eating. And that person didn't get the satiation, didn't get the satiety messages that they were supposed to get. And so really the sad truth is that decreasing calories or controlling calories and dieting only makes an obese person hungrier. And it's really not a personality flaw. It's not a mental weakness. It's not a lack of discipline, as many people think. It really is truly a hormonal dysregulation. And we need to stop blaming the patient. We need to stop blaming the victim for lack of self-control. This is a matter of a hormonal dysregulation. So, the last thing I'm going to leave you before we wrap up for today is there are ways to reduce insulin levels and reduce that weight set point. And that's through some things like intermittent fasting, low carbohydrate diets, keto diets, or carnivore diets. And we'll cover each of these items in upcoming episodes. But the the reality is, if we want to decrease obesity, if we want to, focus on weight loss, we need to focus on insulin, and we need to drive those insulin levels down. That's the takeaway message from this entire episode. So, thank you so much for watching. I really appreciate you guys taking the time to listen. I hope you learned something. I hope this helped open your eyes to how obesity is not a personal flaw. It's not a mental lack of discipline. It's really a hormonal dysregulation. And these poor folks that are obese are, their brains are not signaling them to stop eating. So it's not really their fault, and we have to stop victimizing those people. But anyway, thank you so much for watching. And next week, we'll pick up on some additional topics. We'll cover some additional hormones. And down the line, we'll talk about fat storage and hormones released from fat. And we'll talk about other things like managing glucose levels and glucose spikes. We'll talk about things like diet control and what kinds of diets there are available for you to try and for you to do. So thanks so much for watching, and I'll catch you in the next video. Take care.